Oh, hello. Hello, everyone.
Uh, I have the opening first. Can I have opening? Oh, hello.
Hello, hello. I can hear you.
This is Mustafa. Today we invite he to come to our Google Developer Student Card, National University of Science and Technology. He is a Google Cloud Certified Data Engineer and a Google Developer Library author. And today he comes to here and introduce about the Google Cloud Platform. Let's invite him. Thanks. Okay, Mustafa.
Okay. Yeah,
Thanks.
thanks very much for that. Yeah, so my name is Mustafa Dikunle, and today I'm from Nigeria. If you don't know, I'm a data engineer at Number, and I do data engineering day to day. I'm a Google Cloud certified professional data engineer, and I also write about Google technologies on the Google Developer Library. So I've been using Google Cloud for over 2 to 3 years, and I've been very familiar with how Google Cloud works and how we can use Google Cloud to better our infrastructure and also make sure that our business is scalable and we are deploying a modernized and very good infrastructure online. And so for today, we all know that consumer expectations over the last 20 years have radically changed. And customers now expect a connected global digital experience in real time. Many businesses, especially large traditional enterprise, they built their IT infrastructure on premise. So legacy system and applications make up the organization IT backbone. And also, this legacy system and application, they struggle to achieve the scale and the speed needed to meet modern customer expectations. So business leaders and IT decision makers constantly have to choose between maintenance of a legacy system and investing in innovative new products and services. So for today, in this session, I will explore the challenges of an outdated IT infrastructure, and also going to describe how businesses can modernize their infrastructure using cloud technology. For the first part of this talk, I'm going to introduce infrastructure modernization as the core topic. And in particular, I would examine the compute options available in the cloud and the benefit of each of them. For the second part, I'm going to focus on application modernization. And as we all know, applications are not new, they are not new in the cloud. But cloud technology enables business to develop, deploy, and update applications with speed, security, and agility. In, I would also talk about App Engine, a Google Cloud solution that lets application developers build scalable web and mobile applications on a fully managed serverless platform. And for the final part of this talk, I'm going to present application programming interface or APIs. And we are going to explain how they can unlock value from legacy systems, enabling business to create new values and also monetize new service. I would also cover Apigee, a Google Cloud platform for developing and managing APIs. And I'll then conclude the talk by summarizing the key points and offer additional resources for you if you want to learn, if you want to continue learning. And typically, you don't need to be an IT specialist, you don't need to be a professional to be able to understand this session or develop business value from your business. So let's get started. For the first part, we'll be talking about modernizing IT infrastructure with Google Cloud. And new businesses born into the cloud are challenging old business models. So typically, scale is no longer a competitive advantage. It is now a normal thing. Many organizations are very aware of this threat coming from digital disruptions. Organizations want to know how to best respond to threats. How can they survive and thrive in this new cloud era? For many businesses, infrastructure modernization is the foundation for digital modernization. So in this part, I'll begin by explaining what it means to modernize an IT infrastructure and why it matters. Then I'm also going to talk about the different compute options available. Then I'm going to cover private, hybrid, and multi-cloud architecture and what we mean by each of them. I'm also going to briefly go over Google Cloud Global Infrastructure, and I'm going to conclude with the compute solutions for setting up or modernizing IT infrastructure. So let's get started. Central to an organization's ability to thrive in the new era is the way in which they structure and use their IT resources. This could mean moving away from investing resources to run and maintain existing IT infrastructure to focusing more on creating new higher value products and services. With cloud, organization can develop and build new applications to drive better engagement with customers and employees faster, securely, and at scale. And ultimately, leveraging cloud technology to truly transform a business requires new collaborative models, changing cultures and processes, and enabling team productivity and innovation. Enterprises are also seeing significant financial benefits from adopting cloud as their approach to IT moves from buying fixed capacity to paying only for what they use, changing the economics of technology investment. For most organizations, owning and operating infrastructure does not differentiate their business. In fact, it's often a burden. It limits an organization's staff in several ways. For example, organizations have to undertake laborious tasks related to infrastructure procurement, provisioning, and maintenance. They are also using legacy systems that are old and they don't add value to the business, other than keeping the lights on and don't support business change. They cannot scale with any ease because they are logged into what they have on premise and they are forced to pay over the provision for peak usage. One option for reducing this burden is to outsource the company's IT infrastructure as much as possible and migrate to the cloud. But before we talk about migrating to the cloud, let's go back to a time before the cloud. The first step in moving away from what we call an on premise infrastructure is what we call colocation. And during colocation, a business sets up a large data center. Then other organizations can rent parts of that data center. This typically means organizations no longer have to pay for the cost associated with hosting the infrastructure, but they need to still pay to maintain the infrastructure. With both on-premise and colocation, value creation only starts well after a substantial amount of capital expenditure or capex is committed, which is what we call capital expenditure. So, given that hardware is often heavily utilized or underutilized, even in colocation model, engineers found a way to package application and their operating system into what we call virtual machine. So, what are virtual machines? Virtual machines shares the same pool of computer processing, storage, and networking resources. Virtual machines optimize the use of available resources and enable business to have multiple applications running at the same time on a server in a way that is efficient and manageable. Most companies use virtual machines to optimize their use of data centers, whether on-premise or co-located. The problem, though, is that there's still a cap to the physical capacity of existing servers, and companies still have to commit to a substantial amount of capital expenditures upfront. Many companies are now outsourcing their infrastructure entirely. They are growing to deliver their product and services to customers regionally and globally and need to scale quickly and securely. Setting up and maintaining data centers and network connections that are optimal for their needs is expensive. They don't see the benefit of owning their own data centers if they can outsource to a public cloud that offers infrastructure as a service. So this typically means IT cost is being shifted from being capital expenditure heavy to more operational expenditure heavy. So outsourcing your IT needs at the infrastructure level is what we call infrastructure as a service. And public cloud providers such as Google Cloud offer several services to help you modernize your infrastructure. If your organization chooses to, it can move some or all of its infrastructure away from physical data centers to virtualized data centers in the cloud. Google Cloud provides you with compute, storage, and network resources organized in a way familiar to you from your experience with physical and virtualized data centers. The maintenance work is outsourced to the public cloud providers, so it is easier to shift a larger proportion of the company enterprise to build process and application that move the business forward. Outsourcing IT resources gives the company flexibility, but requires its team to continue managing things like web application security. This is the information security that specifically deals with websites, web application, and web services. So in this scenario, you would pay for the resources you allocate. For example, when you set a number of virtual machines, you'd pay for those particular resources that you allocate. If you want a more managed service, cloud service providers offer something called a platform as a service. In this case, you don't have to manage the infrastructure, and for some services, you only pay for what you use. As cloud computing has evolved, the momentum has shifted even further towards managed automated infrastructure and services. Google Cloud, for instance, is known for its global access to a pool of configurable resources for every layer of IT infrastructure in the form of paid services. Let's discuss some key advantages of using public cloud services to modernize or even set up your IT infrastructure. The first is that cloud reduces the need for IT teams to act as a gateway to technical resources such as network security, storage, compute power, and data. You can think of the cloud as an on demand self service for anyone in the business. Next, there is a broad network access. This means that access to data and compute resources is no longer tied to a particular geography or location. Now, team can access compute resources and data with little to no latency. For the third one, resources are distributed across a global network of data centers. If one is down due to natural disaster, for instance, another data center is available to prevent service disruption. This is referred to as resource pooling. Then for the fourth one, companies can scale up and down instantly due to availability of on-demand cloud resources. This rapid elasticity means businesses can serve their customers without interruption in a cost-effective way. And finally, cloud is a measured service, which means companies have a lower upfront or capital expenditure because they don't have the need to purchase their own data centers, equipment, or maintain their IT infrastructure. If you have decided to modernize your IT infrastructure, business will be wondering what options are available. Let's talk about the options that are available. You might be wondering what options are available to you. So let's explore the three options that you can use to modernize your infrastructure. The first of them is virtual machine, the second, containerization, and the third, serverless computing. First, let's talk about some key terms that are going to help us on this journey. So, in the context of computing or in the context of cloud computing, compute or computing refers to a machine ability to process information, to store, retrieve, compare, and analyze it, and also automate tasks often done by computer programs, otherwise known as software or application. So traditionally, the hardware available for computing could only run a limited amount of software and application. As we discussed earlier, virtualization changed this. Virtualization is a form of resource optimization that allows multiple systems to run on the same hardware. These systems are called virtual machines or VMs. This means they share the same pool of computing processing, storage, and networking resources. Virtual machines enable business to have multiple applications running at the same time on a server in a way that is efficient and manageable. The software layer that enables this is called a hypervisor. A hypervisor sits on top of physical hardware and multiple virtual machines are built on top of it. It is like having multiple computers that only use one piece of hardware. Virtual machines are the first compute option for infrastructure modernization. The second is container. Container follows the same principles as virtual machine. They provide isolated environments to run your software services and optimize resources from one piece of hardware. However, they are even more efficient than virtual machine. Virtual machine recreates a full representation of the hardware. By contrast, containers only recreate or virtualize the operating system. This means that They only contain exactly what is needed for the particular application that they support. Containers offer a far lightweight unit for developers and IT operation teams to work with and provide a range of benefits. They start faster, they use a fraction of the memory compared to booting an entire operating system. Containers give developers the ability to create predictable environments that are isolated from other obligations. Building an apartment block. So when you're using containers, it is like building an apartment block to use a prefabricated unit. In other words, you build the units offsite and then essentially lay them on top of each other. This means that any problem that arises is easy or easier to isolate and fix. It also means that individual apartments can have unique designs with different features because they are all compartmentalized rather than one giant unit. This is what containers do for your application. So if a customer asks for a new feature or a change in the application, developers can easily make an update to that particular part of the application without affecting the rest. Containers are able to run virtually anywhere, which makes development and deployment very easy. They can run on Linux, Windows, and Mac operating system, on virtualized machine, bare metal, which means directly on the hardware on a developer's machine or in data centers on premise or of course in public cloud. Containers improve agility, strength, and security. They also optimize resources and simplify managing applications in the cloud. Many businesses have a mix of virtual machines and containers. However, as IT infrastructure setup become more complex, businesses need a way to manage their services and machines. For example, businesses can have millions and millions of containers. This means that keeping them secure and making sure that they operate efficiently can require a significant oversight and management. Kubernetes is an open source Kubernetes is an open source cluster management that provides automated container orchestration. In other words, Kubernetes simplifies the management of your machines and services for you. This improves application reliability and reduces the time and resources you need to spend on development. You need to spend on development and operation, not to mention the relief from the stress attached to these tasks. So Kubernetes makes everything associated with deploying and managing your application easier. So now let's talk about the final part, which is serverless computing. Serverless computing doesn't mean there are no servers. Serverless computing means that resources such as compute power are automatically provisioned behind the scenes as needed. This means that businesses do not pay for computing power unless they are actually running a query or application. At its simplest, serverless means that businesses provide the code for whatever function they want, and the public cloud provider does everything else. For this reason, serverless computing solutions are often called functions as a service. Some functions are a response to specific events, like a file upload to your cloud storage or changes to your database record. You can write the code that defines the responses for those events or to those events, and your cloud providers does everything else for you automatically. Today, most of the world enterprise computing still happen on premise. It hasn't moved to the cloud yet because path forward is complex, daunting, and full of difficult decisions. Sometimes workload remain on premise due to compliance and operational concerns. So how do you modernize the infrastructure you have built without jumping completely to the cloud? How do you bridge incompatibility architecture while you transition? How do you maintain flexibility and avoid locking? Although we all know that there are many benefits to deploying cloud first or cloud native application and system, many enterprise have complex need they will involve that will involve some on-premise infrastructure working in conjunction with public cloud services provided by companies like Google Cloud. Private cloud is where an organization has virtualized servers in its own data centers to create its own private on-premise environment. This might be done when an organization has already made significant investment in its own infrastructure, or if for regulatory reasons, data needs to be kept on premise. For the second part, which is hybrid cloud. Hybrid cloud is when an organization is using some combination of on premise or private cloud infrastructure and public cloud services. This is the situation many organizations are currently in. Some of their data and applications have been migrated to the cloud. Others remain on premise, and interconnect between the private and public cloud allows interoperability. Multi-cloud is where an organization is using multiple public cloud providers as part of its architecture. The organization needs flexibility and secure connectivity between the different networks involved. An organization might choose to use either an hybrid cloud, either a hybrid cloud or a multi-cloud if they want to incorporate specific elements of the public cloud in order to take advantage of the key strengths of that provider. When organizations are considering to move to a hybrid cloud or a multi-cloud solution, they are often concerned about how easy it will be to move an application from one cloud to another. Google believes that being tied to a particular cloud shouldn't get in the way of you achieving your goals. Instead, they typically believe that in an open cloud, users have the right to move their data as they choose at any time they want. If organizations have the power to deliver their apps or on to different cloud providers while using a common development and operation approach, this will help them meet their business's priority and rapidly accelerate innovation. Open source in the cloud preserves an organization control over where they deploy their IT investments. Google Cloud has created Anthos, which is an open application modernization platform that enables users to modernize their existing application. They can also build new ones and they can run them anywhere. It also allows users to build an application once and roll it whenever you want or wherever you want, on premises or on Google Cloud, or even on a different public cloud. This helps accelerate application development for your organization or for your business. These examples of open source solutions in the cloud enables businesses to leverage Google Cloud infrastructure and deploy applications using Google Cloud solution on premise or using another cloud provider. The reliability and resilience of the cloud infrastructure is critical to business operation and success. The major takeaway from this is that every organization needs to think about their cloud strategy and understand the available options. Google Cloud provides a range of infrastructure solutions to help businesses modernize and manage their customers. We are going to discuss VM-based computing options, including Compute Engine, the Google Cloud VMware Engine, and the bare metal. Then next, we'll talk about Google Kubernetes Engine, or GKE, which is a container-based computing option. And finally, we will now explore the three serverless options, or the three serverless computing options, which are the App Engine, the Cloud Functions, and Cloud Run. We'll just explore three out of the serverless options on Google Cloud. So what is Compute Engine? Compute Engine is a computing and hosting service that lets you create and run virtual machines on Google's infrastructure. Compute Engine delivers scalable, high-performance virtual machines running in Google innovative data centers and worldwide fiber network. Compute Engine virtual machines boot quickly, and they also come with persistent disks. They also come with persistent disk storage and deliver consistent performance. This solution is ideal if you need complete control over the virtual machine infrastructure. It is also useful if you need to run a software package that can't easily be containerized, or if you have an existing virtual machine image that you want to move to the cloud. Another virtual machine based solution is Google Cloud Virtual Machine Engine. This is a type of software that lets you run on a virtual machine. Google Cloud VMware Engine is a fully managed service that lets you run the virtual machineware platform in Google Cloud. Google manages the infrastructure, networking, and management service so that users can use the virtual machineware to perform efficient and secure operation. The final virtual machine based compute solution that we'll cover here is bare metal. Bare metal help you migrate many existing workloads to the cloud easily. However, some specialized workloads are difficult to migrate to a cloud environment. This workload requires hardware and complicated licensing and support agreements. Bare metal enable users to migrate specialized workload to the cloud while maintaining your existing investment and architecture. This allow users to access to an integration to access to different resources and also integrate well with Google Cloud services with minimal latency. Now let's discuss Google Cloud container-based solution, which is the Google Kubernetes engine, often shortened as GKE. The Google Kubernetes engine provides a managed environment for deploying, managing, and scaling your containerized application using Google infrastructure. The GKE environment consists of multiple machines, specially or specifically compute engine instances grouped together to form a cluster. GKE allows you to securely speed up development, streamline operation, and also manage infrastructure. When you're moving to the serverless computing solution, we have the Google App Engine. And the Google App Engine is a platform as a service and cloud computing solution for developing and hosting web applications. It lets application developers build scalable web and mobile backends in any programming language on a fully managed serverless platform. This typically means application developers can focus on writing code without having to manage their underlying infrastructure. Google Cloud allows you to build applications in your favorite programming language with your favorite dependencies and tools and deploy them in seconds. It abstracts away all infrastructure management by automatically scaling up and down from zero almost instantly, depending on the traffic. Cloud Function is a serverless execution environment for building and connecting cloud services. It offers scalable pay-as-you-go function as a service to run your code with zero server management. Cloud Function also offers a simple and intuitive developer experience. You or your developers can simply write your code and let Google handle the operational infrastructure. With Cloud Functions, developers are also more agile as they can write and run small code snippets that respond to events. How you build your architecture influences how your business or how businesses harnesses the application that you build, manages your data, and ultimately develop and thrive with this ever-evolving digital age. So whether you are able to embrace innovation or whether you are constrained by your cloud environment is determined by the choices you make. So leveraging the right application in your business can transform how you work and also unlock new value. Application development in the cloud doesn't typically belong to the IT team, and it belongs to everyone within the organization. So that's all for the first part. Do you want to ask your question now before we move to the second part? Any question?
Okay, can I ask some question?
Yeah, go ahead.
Okay, I have some experience in App Engine. I host a Python application web server on App Engine, and it need to connect to database. I use Cloud SQL to connect, but I want to ask, did we have any because in this project, it need to use the proxy. You need to throw proxy to connect Cloud SQL. Do we have any solution to connect Cloud SQL directly?
Directly to App Engine.
Yeah.
Do you mean connect some? Yeah, yeah. So I think you can build a VPC, a virtual private cloud network for it, and you can just open. Typically, you don't want your database to have an external IP address for security reasons. So you can connect the internal IP address of your Cloud SQL instance to just talk to your App Engine directly, or you can even grant service. You can grant permission to service accounts that can just write your data to your database directly.
Oh, okay. I know that I know PVC is private virtual cloud. You can stay out the
Yeah.
same application or service in the same network that you can use in the internal application or service together. How about I just host a cloud SQL and connect with outside application? Maybe I hold a application in my maybe local host, my own laptop. Can we
Mhm.
directly connect it?
To Cloud SQL.
Yeah, cloud SQL.
Yeah, yes. You can connect. So when you deploy your Cloud SQL instance, you can have the choice to select to have an internal IP address or an external IP
Yeah,
address.
yeah.
So yeah, so with the external IP address, you can obviously connect to external clients, not only from your local device. You can even connect to a client server, maybe a business server. So, but typically, when you're making that kind of connection, you may want to use the cloud VPN so that it's going to create a secured connection and anybody cannot just access your connection. So when you're talking to an external application or an external resources outside the cloud, you typically want to use cloud VPN so that it can help you to protect the connection between them. So connections between Google Cloud or within Google Cloud, they are encrypted by default. But when you're going outside, you typically have to protect it by yourself. So you can obviously do it, but I'd advise to set up a cloud VPN connection.
Okay, I see. Thanks. Thanks.
Yeah, okay, yeah, that's nice. So moving to application with Google Cloud. So application and computer programs or software that help users do something in this digital age are everywhere. So you can think about many applications that you interact with on a day-to-day basis. Customers now expect intuitive, well-functioning application that enable them to do things faster as business capacity to meet that demand influence their ability to thrive in the cloud era. During this section, we are going to explore how businesses can modernize their existing application and also build new ones on the cloud. In particular, I would also cover the 5 common change patterns for businesses who want to modernize their application. I'd also consider some key applications development challenges that businesses face. Then I'm going to highlight the two Google Cloud solutions, which is Google Kubernetes Engine and App Engine. Applications have been developed on-premise for years, and they are still developed on-premise. But on-premise application development often slow down businesses. This is because deploying an application on-premise can be time-consuming and require specialized IT teams, and any new changes can take up to 6 months or even more to implement. This then creates friction within different parts of the business. Cloud technology enable businesses to develop and manage applications in new ways. They are more agile and responsive to user needs. In other words, businesses are able to develop applications and deliver updates quickly and respond to the needs of their customer rapidly. People often assume that modernizing an application with cloud technology can be only done in one way, which is moving everything to the cloud at once. So that can be pretty very risky, especially for large applications. The good news is that this is just one approach, and moving an application to the cloud doesn't need to be done all at once. Google Cloud has identified 5 common patterns that businesses can adopt when they want to move or when they want to modernize their application. A business can move the application to the cloud first and then change them, or they can change their application before they move them. They can also invent in greenfield, or they can also invent in brownfield, or they can just move the application directly without changing any of them. For the first part, moving application first and then change them. If an application or if an organization wants to take a relatively conservative approach to modernizing application with the cloud, they might have to move first and then change. So this part typically starts with a lift and shift program for selected application. The migration of this application typically brings minimal changes to the ways of working within the organization. But once the application are running in the cloud, they are ready to be updated more easily than when they were running on premise. And after the first set has been re-architected and optimized in the cloud, then businesses can now move further applications into the cloud. So that's the first approach. The second approach is to change application before they move. If an application wants to take a more aggressive approach to modernizing its application, they can re-architect application first and then move to the cloud and then make them to be cloud ready before they now migrate them to the cloud. For the third part, organizations for inventing in greenfield, for some organizations, their initial interest in the cloud is because they want the ability to build new innovative applications very quickly. They may not want they may not want to or be ready to move their existing application at this point. So when we talk about a greenfield strategy, it's basically a strategy of building an entirely new infrastructure and application in the cloud. Investing in greenfield allows you to build innovative application that will help drive the business forward, but it does require agility, access to diverse development skill sets, and strong support from leadership when you want to adopt this kind of strategy. For the third strategy, invent in brownfield. A brownfield strategy is to invent new application in the cloud environment that will replace an existing legacy application that remain on-premise. The legacy application is only retired after the new application is built. So although this can lead to redundancy, and this redundancy can be comforting through minimizing risks, especially for mission critical application, but it also comes with increased costs associated with running application in both places if they are using a brownfield approach. And the final approach, you can also move application without making any changes. So it is worth noting that building cloud native application isn't appropriate for all scenarios. For some use cases, it is efficient to leverage the cloud just to modernize the infrastructure layer. So use cases involve switching to cloud storage to decommission an on-premise data center or creating a virtualized environment for disaster recovery. So these are some examples of when organizations can decide to move their application to the cloud without changing anything. So many businesses professionals, they share similar concerns around application development processes and timelines. Creating a new application within an organization can be a challenge. Traditionally, when business professionals want a new application, the tech or IT team has to do a lot of work to identify features, estimate capacity, define a technical architecture, or even consider integration with other systems. And they can allocate resources even before a line of code is written. So once these requirements are agreed on, a new application would have to be designed, built, tested, integrated, and deployed. But new needs often compete with existing projects for time and resources. So for some teams or for some businesses, this means spending just as much time creating and managing environments as it spends building business value. So these are some of the challenges that comes with application development. And developing a cloud native application avoids the hassle of trying to create something that is constrained by legacy systems and outdated processes. Building a new application in the cloud frees team up from worrying about environment so they can focus on creating features instead. So whether you are building an application on-premise or in the cloud, developers still need to make decisions about overall network architecture, the choice of database, and the type of server. All of this can slow down the application development process and even the launch of application. The challenge for building apps using an on-premise infrastructure can outnumber those of cloud-native apps and can often be frustrating for developers and business professionals. Developers want to be creative and innovative by building new solutions, not spending hours maintaining the infrastructure. When developers get too far removed from the tasks that they enjoy, so naturally they start to seek out more interesting job opportunities that allow them to focus on building new apps and technology. So this can also lead to losing a key member of your team. And when you lose a key member of your team, you have to go over the stress of replacing that person. And the organization also loses the intangible knowledge that good developers take with them when they leave. Developing cloud native applications avoid the hassle of trying to create something that is constrained by a legacy system and outdated process. So building a new application in the cloud means you can be more agile in your development. It also frees team up from worrying about environment so they can focus on creating features, which is where customers get real value. Updating already existing applications that have been typically built on premise present difficulties too. And something else. For those of you that code, you know that there are sometimes that when you make changes to something, they can break another thing. And when an application is updated and an entire application needs to be deployed and tested, even if the change is only small, this makes implementation updates a lengthy and potentially risky process. Because you just change one line of code and you want to redeploy the service, you have to also redeploy all the service once and for all again. And that can lead to a whole lot of time wasting and making the development or the deployment process very stressful. So when building new application or modernizing existing one, you typically want to use a microservice architecture because it can help you reduce a whole lot of problems. And this type of architecture involves the separation of a large application into small, loosely coupled services. The code base for each application or for each service is modular, so it is easy to determine where the code needs to be changed. And when a code change is required, the service can be updated and deployed independently. In addition to this, each service can be scaled independently depending on its specific requirement. And that's the benefit of using a microservice architecture. So adopting an automated continuous integration, which we call CI/CD, continuous integration and continuous deployment, can help you increase your application release velocity and reliability. You can test and roll out changes incrementally. This approach enables you to lower the risks of regression. You can also debug issues quickly and roll back to the last stable build if necessary, all without interrupting services for your users. Here's the important bit. When some organizations have been able to adopt the CI/CD to build application faster, but not always the high quality that customers demand. So this happens because they don't invest enough in building quality into the process. So when you're building your CI/CD pipeline, you also want to invest quality into the process of deploying it. And when building an application, you need to consider how quickly your system can recover from downtime. If you are not able to recover from production infrastructure failures quickly, it does not matter how quickly you deliver software. You won't be able to deliver better customer experience. If your business is not fault tolerance or does not have a reliable failover, it's going to lead to a churn in the amount of customers that are going to have, and customers are going to leave you for other businesses. So there are some Google developer tools or the Google Cloud developer tools that help us to release software at high velocity while balancing security and quality. Under this, we'll talk about GKE and App Engine. Containerization allows developers to divide an application design into individual compartments. The advantage is that part of the code can be updated without affecting the whole application. It also builds resilience because one error doesn't impact the whole application. Containerization allows developers to divide an application design into individual compartments. Part of the code can be updated without affecting the whole application. This also builds resilience because one error doesn't impact the whole application. And as businesses create and scale more and more applications, They need a way to manage or orchestrate their containers. So Kubernetes is an open source container orchestration system for automating computer application deployment, scaling, and management. And the Google Kubernetes engine, or GKE, is the Google Cloud Managed Service for container orchestration. And GKE enables rapid application development and iteration by making it easy to deploy, update, and manage your application and services. Now, you might remember that we talked about serverless computing from the previous part that we discussed as an option for modernizing IT infrastructure. So the same option can also be used for application development. With serverless computing, your cloud provider, they manages even more of your architecture. You can write the code for the functions you want, and the cloud provider updates and adapts the container or virtual machines as needed to make that change. So let's talk about some serverless products on Google Cloud. The first we'll talk about here also is App Engine. App Engine leverages serverless computing to enable businesses to develop applications. An App Engine is the platform for building scalable web application and mobile backends. App Engine will scale your application automatically in response to the amount of traffic it receives. So you only pay for the resources you use. For example, when you are building an application, App Engine manages the hardware and networking infrastructure required to run your code. So developers no longer need to spend valuable time doing this. During deployment, App Engine will scale your application automatically in response to the amount of traffic it receives. So you only pay for the resources you use. You just need to upload your code and Google will manage your app availability. That's one of the functions of App Engine. You can also easily run multiple versions of your app to test new features or designs with end users. So because there are no servers for you to provision or maintain, the monitoring and maintenance process are very easy too. And that's on the second part of the course. So the next part of the course is to move to the value of APIs. But likewise, before we move to this part, let's see if there are more questions. Any question?
Okay. I want to ask about Cloud Run and VS Cloud App Engine. When we will use Cloud Run instead of App Engine? Yeah,
Okay,
just like
yeah.
it.
So I get. So App Engine are typically optimized for mobile application or for sometimes web application. So they are typically optimized for application services, something that requires an application. That's what App Engine are typically optimized for. But for Cloud Run can help you just to run a code to perform a particular function. So it also operates on the principle of containerization, but it can help you run just any typical service. So let's say I want to use a Python code to do something. I can just put my code on Cloud Run and it's going to do that. But when I want to deploy an application, either a mobile application or a web application, I typically want to use App Engine. Otherwise,
Oh,
I can go for Cloud Run. Exactly.
because I use I use App Engine to deploy my backend. I think I doing wrong. I need to use Cloud Run.
Yeah. So is it an application?
Yeah, it's a web application, but it's not for the mobile. It's for like for web.
Yeah, so mobile and web works with App Engine. I think you are doing it right. Mobile and
Yeah,
web works for App Engine. Yeah, you're probably
but
doing it right.
but maybe App Engine is not suitable for the heavy application. In more suitable for the light one.
There are two types of App Engine. There is App Engine Standard, there's App Engine Flexible. So you may also want to take a look at both of them and see the one that works best for your particular service. So there are two types. There's the flexible and there's the standard. So you may want to check both of them.
Oh yeah.
Yeah, let's move to the third part then. We can ask questions after that once again.
Okay.
Yeah, thanks for that.
Thanks.
So the final part we'll talk about APIs. And APIs are a tool for both digital integration and digital transformation. I'm going to begin by defining the legacy system and identify why they struggle to meet the demands of the digital age. We would also define APIs and how they can modernize legacy systems. Finally, I'm also going to explore examples of how API creates business value. Then finally, we'll take a look at Apigee, which is a Google Cloud solution for developing and managing APIs. So let's get started. So many enterprise decision makers and advocates are constantly choosing between maintaining a legacy system and developing new and innovative projects. Why is this often a trade-off for the business? This is because legacy systems and applications are complex. They are expensive to maintain, and they do not provide the speed and scale required to deliver a seamless digital experience that consumers now expect. A legacy system is an outdated computing software or hardware that is still in use. The legacy system is mission critical, but often not exposed to deliver new services or upgrades at the speed and scale the, at the speed and scale that users expect. So I'll just take that once again. So the legacy system is mission critical, but is often not equipped to deliver new services or upgrades at the speed and scale that users expect. And a legacy system often can't connect to newer systems. So example of a legacy system is maybe a particular device in the business that they've been using for quite a lot of time, and that it works for them. But when you see those systems do not have the facility to connect to newer systems, and they cannot even also go at the speed that a cloud system is going to go at that speed. So the common examples of legacy system may include an HR or employee management system, a banking system, or a databases or data warehouse, or data lakes, or some systems that that are designed for government operations. So all these old systems, they are what we call legacy systems. And these are all different systems to store and manage data. All of these systems, whether they are on-premise or in a private or multi or hybrid cloud environment, they are very valuable to the business because they hold a large amount of data. But unlocking the value of that data is challenging. This is because legacy systems weren't developed to support the implementation and adoption of modern technologies such as the cloud or the Internet of Things or mobile application. They were developed for a time when data was shared in batches. So those legacy systems, they were developed when people share data in batches. Maybe after 30 minutes, they share the data. After 1 hour, they share the data. But now people want data in real time. Immediately I pay for a service, I want the delivery to see it immediately, and it should start bringing it to my particular apartment. So it's not we are not living in an environment or in a world where data are consumed in batches. Data are now consumed in real time because people want instant response to anything they are doing. And this means that legacy systems are not designed to serve data in real time as it is expected in today's digital world. So as a result, legacy system tends to hold organization back from using digital technologies to innovate or improve IT efficiency. Naturally, modernizing IT infrastructure is central to digital transformation so that businesses no longer have to choose between maintenance and innovation. This means that they need a well-designed integration strategy that leverages application programming interface or APIs. So how we can unlock values from legacy system is by using APIs. So we can just expose what we want from those legacy systems to the APIs, and we can consume from those APIs. An application programming interface is a piece of software that connects different applications and enables information to flow between systems. Businesses can unlock value and create new services. They expose data in a way that protects the integrity of the data of the legacy system, and they enable secure and governed access to the underlying data. This allows organizations with older systems to adapt to modern business needs and, more importantly, to quickly adopt new technologies and platforms. APIs enable businesses to unlock values without architecting all of those legacy applications. But it is important to remember that legacy modernization is not the end goal. Rather, it is the way, or it is a way to build long-term flexibility, so an organization can meet evolving needs and better services, or better service their customers. So customers expect real-time, seamless experience across platforms. Businesses now have the opportunity to digitize experience throughout their value chain to meet their customers' expectation. And let's take a look at the API architecture. The web or mobile app are built by internal enterprise developers or by external third-party companies. APIs are built and managed by the API team. So within an enterprise, application developers leverage those APIs to integrate with backend services and other service endpoints. APIs are therefore central to an organization's digital transformation strategy. They enable faster innovation so organization can bring new service and also market quickly and create new business value. That's what API helps us to do. And API started as a tool to facilitate access and integration, and they still serve those functions. But now, APIs can do so much more. When organizations start to think about APIs, or when developers start to think about APIs and build an API first architecture, they can build a new digital ecosystem and create new business value. A digital ecosystem is a group of interconnected companies and products. This involves vendors, third party suppliers, customers, and applications, just to name a few. A robust, well connected, and multifaceted digital ecosystem enables businesses to create and monetize new digital experience. And it is because of these APIs that some of us can connect to the WhatsApp API. We can also connect to the WeChat API to do our to configure our various services. Some people can connect to Twitter API to perform some functions on Twitter. And it's not only for social media websites. Almost all organizations have an API endpoint that they use to open source or even allow developers, external developers, to talk to their particular service or to talk to their legacy system in their own infrastructure. So the more you know about your customers, the better you are able to truly offer a truly integrated end-to-end digital experience. And the more service you have in your ecosystem to connect to those customers, the more you will learn about them. So APIs are not only a long-standing integration technology, they are the fundamental building block for digital transformation. So I want you all to leverage digital and also leverage API. So legacy systems like CRMs, ERPs, SOAs, databases, data warehouses, data lakes, they provide business value and they also provide business data, but don't provide the future and capability at the rate of change demanded by today's users. Modern application, on the other hand, provide connected experience and can be rapidly updated to meet user demand. Applications that provide this connected experience to end users must be able to do so securely and at scale. Developers therefore need to manage the entire application lifecycle. They can connect to different backend systems, including the legacy one, and they are also able to track and analyze the interactions between consumers, data, and service producers. Many businesses started with a small team of developers who were responsible for creating APIs, specifically for modernizing legacy systems and for creating modern applications. But as the company digital ecosystem becomes more complex, the required time and effort to manage hundreds of APIs securely and at scale becomes costly. So, and this is where Apigee comes in. So Apigee is a fully featured API management platform that enables application developers and API providers to create connected digital experience for end users. Apigee bridges the gap between legacy systems. And the Apigee platform also includes an API service layer that provides the runtime API gateway functionality. The Apigee platform include developer services. This means that a developer can access a portal to utilize your APIs for their projects. They can also register their application. Measuring and tracking the performance of API is a critical component in API management. And to wrap things up, I'm just going to go over 3 points. Businesses need to provide seamless digital experience to remain relevant in the cloud era. Legacy system and application failed to deliver the real time, the speed and scale needed to provide those experiences. Modernizing IT infrastructure is essentially a process that breaks down monolithic system and application into the smallest units that use a shared pool of resources as a result. And one new feature request comes in or changes are needed. So each unit can now be updated and deployed easily and at scale when you change from a monolithic application to a microservice application. And for the final point, modernization also involves handing over more and more of the back and maintenance to the cloud providers. This means your IT teams can now focus on innovating and delivering business value instead of wasting time on intensive maintenance. And that's all for our talk. And thank you everyone for listening. So I want to try to pronounce this in Chinese. I think this is Shen Shen. Yeah, did I get it?
Yeah, actually, 谢谢 is thank you the
Okay,
meaning. 谢谢.
okay. Oh, oh. Yeah, great. Great.
Okay, did
Yep.
everyone have a
So,
problem?
any question? Any
Any question?
clarification?
Okay, I want to ask. Because
Maybe.
I used the Terraform before. Did you know Terraform? You can
Yeah,
fast
yeah.
to build your
For
infrastructure. Yeah.
automating infrastructure development
Wait,
or
Oh yeah,
deployment.
yeah,
Yeah,
yeah.
I know that.
喂，
有听到.
Oh, okay, sorry.
Hey, and the this application or this service will help you to maybe building your infrastructure fast or how what's the advantage of Terraform?
What are the advantages
Yeah.
of Terraform? Okay, the first one is that it helps to automate the development of infrastructure or the deployment of infrastructure. That's the first one. Number two is that it helps you to create those infrastructure using templates. So there's a template for creating a compute engine instance. There's a template for creating a VPC network. There's a template for creating a database. And when you need to create a similar application, you do not need to start clicking on each and every one of them. Click on virtual machine, click on create a complete engine instance, change the name, change this. So you can just go to your templates and just edit those templates. And when you edit those templates and you want Terraform init, Terraform plan, then Terraform apply, then voila, the service is being created. So that's another one. So it helps to simplify a whole lot of application deployments, and it also saves time. So it saves time. It's like it automates it for you. So and you know that it's just with configuration files that you easily create all these things. So sometimes to create services you have to go to different applications. Or if you are using the console or you are using the command line, depending on anywhere you want to use. But when you use Terraform, with just configuration templates, you can easily deploy infrastructure, and it's something that really works, and it's not only on Google Cloud. So there's Terraform. There's a Terraform service on Microsoft Azure and AWS also. Terraform is it's a popular tool that developers use when they want to automate their deployment of the infrastructure. So I think you can start using it slowly. You can start using it slowly. Maybe just for creating a complete engine instance, you can test it out and see how fast it can help you create it. And another thing that can also help you do is that when you want to create a whole lot of resources, let's say I want to create um, two complete engine instance, um, two VPC network, some databases, some firewall rule, some this and some that. I can just write the configuration code for everything on Terraform and even set the dependencies. I can link a virtual machine to a VPC network. I can link another virtual machine to another VPC network. I can also set the firewall rules for each and every one of them. And when I just initialize Terraform and plan it, then apply it, it's going to get created. So it really helps.
Yeah. Oh yeah, I know Terraform and I used it before. So the most of us saying the Terraform is a trending for the next generation of building cloud infrastructure. Is a trending.
Uh, 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 yeah, I suppose it's trending because it really helps to make your work very easier. It really helps to make your work very easier. So the more people adopt it, the more faster they can easily deploy infrastructure. And when people keep jumping upon it, so there are two things. The first is that each and every cloud provider also they also want to make developing infrastructure as seamless as possible. So as those infrastructure are continuously making developing infrastructure or developing applications very seamless, they're also competing with Terraform. So it may get to the nearest future whereby to just create a complete ending instance. Maybe you just click on two things and it will get created. So but typically Terraform still works and Terraform will still be relevant.
Okay, thanks.
Yeah, I know it's night for you all. So thanks very much for showing up. I think you'll probably be in 9 o'clock at the moment.
Yeah, now it's 9 o'clock, 9:16.
No, okay.
Okay, we really appreciate most of our come to our Google Developer Student Car NYUST here. So we thank a lot here, and this is very good opportunity to come here and let everybody student know about the Google Cloud Platform and every infrastructure related topic. So